Hey there, math fans. Welcome to Test 6, Lesson 3. Swords ready? Let's go. Our lesson objectives for today are to write expressions to match a situation, to use ratio to relate parts to a whole, and to find the greatest common factor of two numbers. So let's begin by writing expressions to match a situation. So here we have a situation. Marcus went to the shop and bought 2 loaves of bread, which we'll call A, a jug of milk, which we'll call B, and 4 chocolate bars, which we'll call C. His purchase cost $7.92, and we want to write an expression to match his purchases. So the first thing I'm going to do is notice that the loaves of bread are A, the jug of milk is B, and the chocolate bars are C. He bought them, so I'm going to use addition to express it, and the answer is going to be $7.92. Now I'm going to start by looking at the loaves of bread. He bought 2 loaves of bread, so that's going to be 2A. 2 times A, 2 loaves of bread. Plus he bought 1 jug of milk, so that's B. And 4 chocolate bars, which I can write as 4C. When I add those up, it should equal $7.92. So what I've done here is I've written an expression that matches what Marcus bought at the store. Here's another situation. Lauren bought a sweater, X, 2 pairs of soccer cleats, Y, and 3 soccer balls, Z. She returned one of the soccer balls later and found she'd spent a grand total of $85.26. Write an expression to match her purchases. Pause the video here and see if you can write one on your own, and when you come back I'll have the answer for you. Alright, so Lauren bought 1 sweater, and that's X, so I'm going to start by putting in X. She bought 2 pairs of soccer cleats, which are Y, so I'm going to write those 2Y. Now, she bought 3 soccer balls, but she returned one of them later. So I have a choice here. I could either put plus 2Z, because she bought 3 and returned 1, so that'll be 2. Or I could put X plus 2Y plus 3Z take away Z. If I wanted to. It doesn't matter. It will give me the same answer, which will be, of course, $85.26. Trying to write small in here. There we go. Just notice when you're looking at this that 2Z and 3Z take away Z are going to be the same, right? Because if I have 3 Z's and I take 1 away, it will equal 2Z. That's all there is to writing an expression. You just have to look at what she bought. A letter gets assigned to each thing, and then you write it as an equation. Moving on, let's talk about how we can use ratio to relate parts to wholes. So we have here some shapes, and up until now we've mostly been talking about ratio in terms of relating things to each other. So for example, here I would say, how many circles are there? There's 1, 2, 3, 4 circles. And I'm going to relate that to triangles, and I have 1, 2 triangles. And to squares, which would be 1, 2, 3 squares. That's my ratio of circles to triangles to squares. But I can write ratios in other ways too. So for example, I could write blue shapes to green shapes. So 1, 2, 3, 4 blue shapes to 1, 2, 3, 4, 5 green shapes. I can also do ratio of parts to whole. So for example, I could say, what is the ratio of circles to shapes? Then I would say, how many circles are there? Well, there are 1, 2, 3, 4 circles. To total shapes, how many total shapes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Now in that case, you'll notice that I counted the circles both times. And the reason I'm doing that is because I'm doing part to whole. The circles are the part, but they're also part of the whole thing. It's like if you take an apple and you have an apple core. The apple core is a thing by itself, but it's also part of what makes up the whole apple. Okay? So when you're doing a ratio of part to whole, you just have to compare the the one small part, in this case I have 4 circles, to the entire group, which in this case I have 4, 5, 6, 7, 8, 9 shapes, 4 to 9. And now I know this is a little bit out of order, but it's because I want you to do a study jam. So could you please pause the video here and just complete these 2 review questions? And once you've completed them, you can continue with the video. These are the 2 review questions you need to hand in class tomorrow. So pause the video, do these review questions, and then keep going. And our final objective is to find the greatest common factor of 2 numbers. So first of all, what the heck is the greatest common factor? It is the highest number that divides exactly into 2 or more numbers. So if you find all the factors of 2 or more numbers and some factors are the same, which another way of saying that is common, then the largest of those 2 common factors is the greatest common factor. We also abbreviate this as GCF. Sometimes it's called highest common factor. So here's an example. If we have 12 and 30, we do a factor tree for them. So here's a factor tree or factor rainbow for both of those numbers. What I want to do to find the highest common factor is take a look and find out what number shows in these and is the highest. So the biggest one obviously is 30, but I don't have that here. Then I have 15, no 15 over here. 10, there's no 10 over here. 6, here we go. So the greatest common factor, the number that is a factor of both 12 and 30 and is the biggest, is 6. The last thing I'd like you to do today is the study jam for GCFs, or greatest common factors. So this is the website you need to go to, www.tinyurl.com/GCFjam. You'll need to do this on a computer. It will not work on a mobile device. So if that's what you're using, talk to me tomorrow and we'll get you set up on a computer either before school or at recess. Please do the study jam and then also do the test yourself. It's just 7 quick questions. That's it for today. I will see you tomorrow. Have a wonderful night.